Okay. Now the last thing we're going to look at is Cramer's rule. And Cramer's rule is pretty cool. If you've got a system of equations like this, okay, A1 and A2 are the coefficients of your x values, B1 and B2 are the coefficients of your y values, and C1, C2 are your constants, then you can use the determinants of associated matrices to find the x and y values that are the solutions. And this is pretty darn cool, okay, because we're going to find the determinant of just the coefficients of our variables in the bottom of a fraction. We're going to find the determinant. Oh, I don't think I said that we denote the determinant by those, it looks like absolute value bars around a matrix. Instead of having the brackets, when you see the bars, that is saying the determinant. So you can see it around the matrix itself, or you can see it around like just capital A like that, means the determinant of matrix A. All right, and then in the top for the x values, we're going to replace the coefficients of x. See, the coefficients of x were A1 and A2. We're going to replace those with the constants. So these are going to be C1 and C2. We're going to keep that B1 and B2 here. So we've got a determinant in the top and a determinant in the bottom. And then for the y values, we're going to do the same thing. The bottom is going to be exactly the same, just the coefficient matrix, the determinant of the coefficient matrix. But the top, we're going to leave the coefficients of x alone this time, and we're going to replace the coefficients that go to y. So C1 and C2 go there instead. And when we find those determinants and simplify those fractions, then we're going to get the x and y value that satisfies the equation. Now there is one caveat, one little condition here. Because we are dividing by a number, we got to say that that denominator can't equal 0, because I can't divide by 0. So I'm going to say provided that the determinant of A1, B1, A2, B2 is not equal to 0. That's the only condition here, okay? All right, so let's do one of these problems, and that's the end of this little topic, okay? If I'm looking for the x and y values using Cramer's rule, then all I'm going to do is I'm going to say, okay, well, x is equal to, and we're going to have the determinant of 5, negative 4, 6, negative 5 in the denominator. In the numerator, I'm going to keep the coefficients to the y values, and I'm going to replace the coefficients to the x with those constants. Okay, and so let's go ahead and see what happens there. So I'm going to have, remember we're going to multiply this diagonal first, negative 10 minus negative 4 in the numerator. And in the denominator, I'm going to have negative 25 minus negative 24. Let's see what happens. I've got negative 10 plus 4, which is negative 6, over negative 25 plus 24, negative 1. And so we think that our x value is positive 6. Let's see what we get for our y value using Cramer's rule. Okay, so we can say that the y value, remember that the y value has the exact same denominator, but the numerator is going to be a little bit different. We're going to keep the coefficients of x, and we're going to replace the coefficients of y. So we'll end up with 5 times 1 minus 6 times 2, and that's all over. We don't need to do this calculation again because we already did it. So 5 minus 12, negative 7 over negative 1, positive 7. So we think that our solution to this system is 6, 7. Let's see. If I plug this in, 5 times 6 minus 4 times 7, is this equal to 2? 30 minus 28 is equal to 2. Well, that's good. How about 6 times 6 minus 5 times 7? Is that equal to 1? 36 minus 35 is indeed equal to 1. And we have solved this solution using Cramer's rule. Who knew there were so many different ways to solve systems of equations? We learned 3 different ways, actually, to solve a system of equation using matrices. One, we talked about using RREF in our calculator. 2, we talked about using this matrix form of a system and using the inverse of the coefficient matrix, multiplying it by the constant matrix, and that should give us our solution. And then 3, we talked about using Cramer's rule. So, wow, 3 new ways to solve systems of equations.